Okay, so underneath movement and energy, we see a bold-faced term that is defined there. The word inertia. How many people have heard of that before? Okay, anybody know what it is without reading the definition?
The like amount of force it takes to stop or start an object.
It is related to that, yes. Inertia is related to how much force would be required to slow something down or speed it up, absolutely. Okay, that's kind of Newton's first law and Newton's second law and how they relate. Yeah.
I think this might be a different concept, but isn't it when someone gets stopped and still force traveling forward?
Close, also kind of related to it, related more to Newton's second law. Okay? Inertia is basically the word we use to describe Newton's first law. Okay? So Newton's first law deals with the tendency, the natural tendency of an object to do whatever it's going to do in the absence of any other forces, okay, or any unbalanced forces. Okay? So right now, okay, this desk right here, okay, what is it going to do? It's going to stay there. That's Newton's first law. Okay? Newton's first law says that an object at rest will remain at rest unless acted upon by an external unbalanced force. Okay? Are there any forces acting on this desk? Gravity is acting on this desk. Any other forces? If only gravity is acting on this desk, what should the desk be doing?
Going down.
Falling, yeah. What's keeping it from falling? The floor. Okay, so there are two forces acting on the desk, and they are balanced. Okay, the force of gravity pulling the desk towards the center of the earth, okay, and the force of the floor pushing directly opposite that. Okay, that's what we call the normal force or the reactive force. It has to do with Newton's third law. Okay, every action has an equal and opposite reaction. Okay, so when gravity pulls the chair or the desk into the floor pushes back with an equal and opposite force. Okay, it's the reason why if you punch someone, you break your hand. Okay, you hit them, but you don't get to hit them for free. Okay, their face will hit your hand back. Okay, and your hand has less mass.
I'd rather have a broken hand than a broken face.
See, the problem is that they might not break their face because their face has a bigger mass than your hand. The little bones in your hand have less mass, so they'll experience a greater acceleration, which can lead to breaking of the bones in the hand, which is why all like martial sports, boxing, mixed martial arts, whatever, they almost always have padding on the hands, gloves of some kind, okay? Because anyone who fought barehanded is not likely to last very long. You're going to break those small, low mass bones, okay? If you're constantly hitting larger, heavier bones, okay? It's also why in a lot of martial arts, a lot of the parts of the body used for striking are the heavier parts. Elbows, knees, shins, okay? If you're using those, they're heavier, okay? And so they're less likely to be broken, okay, when used to strike something. Okay? Does that sort of make sense? Okay? So inertia talks about the tendency of an object to keep doing what it's doing. If something is moving at a constant velocity, it's also going to keep doing that. Okay? The only thing that could cause it to not move at a constant velocity is an unbalanced force. All right? Now, we don't see this part of the law happen very often on Earth because there's always what force slowing things down? Friction. Yeah, and it could be gravity too. If it's something going through the air, gravity is going to play a part in that as well. Okay, but it's usually friction. Okay, if I was to be out in space and throw a ball, that ball would just go. It would never stop. Okay, I mean, assuming it didn't come into the gravity well of some other planet or something where that would be an unbalanced force. Okay, if I was just out in the middle of space with nothing around and I threw a ball, that ball would travel at a constant velocity in a straight line forever. Okay? It's actually a big deal if you're an astronaut. You don't want to get separated from your spacecraft and have no ability to exert a force, or you'll float away. Okay? Yeah, forever. That would suck. Okay? You just, float until your oxygen runs out. Okay? So that's really not one of the ways I want to go. It's not really high on the list because it's unlikely to happen, but it's there. Okay? Inertia is this tendency to keep doing what you're already doing in the absence of forces. If there is a force, then acceleration occurs. That's how these ideas are tied together. Okay? If there is an unbalanced force, then the velocity will change. All right? So if I've got a ball rolling along the floor okay, it's eventually going to stop because the force that's not balanced is, what's going to slow the ball down as it rolls along the floor? Friction, okay? That's an unbalanced force. It's going to cause an acceleration. So for acceleration to occur, there has to be an unbalanced, or what we call a net force, okay? All right, so make sure you know what inertia is. I almost always have a multiple choice question about it. Okay, it's the tendency of an object to keep doing what it's doing in the absence of forces. Okay? If there is a force, then the velocity will change, and any change in velocity is acceleration. Okay, that's again why I said what I said earlier, which is we don't use the term decelerate in physics. Okay, any change in velocity, positive or negative, is an acceleration. Okay, in fact, I'll throw another one that'll blow your mind. Okay, this is my ghetto physics demo. Roll of athletic tape tied to a drawstring from my hoodie. Okay, this is what happens when you cut money from education. Ghetto physics. Okay, this object is traveling at a constant speed, but it is accelerating. Okay, if it's going to go in a circle, okay, that means it's accelerating. Even though its speed doesn't change, it's always going a different direction. And the only way to make something move in a circle is to pull it towards the center. If I let go of this, okay, which I'm not going to do, I do it in physics 20, so if you want me to let go of it and have it fly right up past your head, okay, like David and Goliath style, okay, I will do that in physics 20. See, this is what it's my catch for you. Okay, if I let it go, it'll travel in a straight line. Okay, it'll go back to that inertia idea. There'll be no unbalanced forces, and it'll just fly off in a straight line. Okay, but in order to make it go in a circle, the string is always pulling it back towards the center. So it's always accelerating. So acceleration doesn't necessarily mean it's going faster or slower. It could just mean it's turning. That still counts as a change in velocity because velocity is vector. Okay, and even if I change the vector, I'm changing the velocity. Okay, so any of those are considered an acceleration. All right. So the formula that we're going to use is on your formula sheet. Okay, and that is, I think it's written on your formula sheet like this. Acceleration is delta V over delta T. Okay, so we got to talk about delta, the triangle. Okay, delta is the Greek letter D. In math and physics, it stands for change. Okay, so anytime you see delta anything, it means the change in that variable. And the way you calculate change is to take the final and subtract the initial. Okay, so if I see delta V, that means final velocity minus initial velocity. If I see delta T, that means final time minus initial time. We rarely ever use the delta T part. We're usually just told how long something takes. Okay, so we typically write this formula this way. Okay, now we've used that formula already because we were using it on velocity versus time graphs to calculate acceleration in different parts of the graph. Okay, now if I'm looking at a velocity versus time graph, okay, and it looks like this. Okay, so meters per second and seconds. Is that object accelerating?
Yeah.
It is. Okay, it's accelerating negatively. Okay. Does its velocity change? Does time change? Yes. Okay. So would this change in velocity be the slope of the line? That might be useful somewhere. Like, you know, stuff we were working on maybe yesterday. Okay. So when I calculate the slope of this line, okay, I'm essentially finding the average acceleration of the object, okay, using the trend line, right? Final velocity minus initial velocity divided by time. Okay? That's going to give me meters per second divided by seconds. So the units for acceleration are going to be
meters per second
meters per second, which we typically write meters per second squared. Okay, now sometimes that bothers people, that's squared in there. It does not mean the number is squared, okay? It doesn't mean anything like that. This is just what happens with the units, okay? If I have meters per second and I divide by seconds, okay, essentially like fractions, what do I do with fractions when I want to divide them? Flip and multiply. Okay, so when I flip this, and I think I've gone over this already, but I'm going to go over it again just in case. Okay, then I have 1 over seconds. What's meters times 1? Meters. What's seconds times seconds? Seconds squared. Okay. I don't care which way you write it. You could write meters per second, and I would know what you meant. We just typically write it that way. Okay. All right, so let's look at a simple example here. We've done ones like this one already on graphs. Okay, but let's say we have this plane here. Okay, and it starts from rest. That's an important term you're going to need to know. Okay, something starts from rest. How fast was it going? Right. Okay. What if something comes to rest? Then it stops. Its final velocity would be 0. So rest always means stop. Okay. Comes to rest, final velocity is 0. Starts from rest, initial velocity is 0. Okay. Just know the term rest. Know that that's what it means. Okay. So in this one here, we know VI is 0 meters per second. Okay. The plane accelerates down the runway, and at time 29 seconds, is moving at 72 meters per second. Okay, where the plus sign indicates to the right. All right, calculate the acceleration of the plane. Do I have everything I need to use this formula? I do. I mean, Ti is going to be 0, so okay, I can really just say Vf minus Vi over T, 72 minus 0 divided by 29 seconds. Okay, it's going to give me positive 2.5 meters per second squared. Okay, so that plane goes 2.5 meters per second faster every second. Does that seem fast? Okay, it's actually not very fast. If something falls, it accelerates at this rate. So if you were in that plane, you would feel the seat pushing on you with a force of about 1/4 of your weight. Okay, we would say this would be 0.25 Gs. Okay, so not even 1 G. Sitting in your desk, you feel 1 G. Okay, the seat of your desk pushes back up on you with 1 G worth of force. You feel your weight. Okay, so in this plane, the seat would push on you from the back with only 0.25 Gs. So you feel a gentle push in your back, kind of like when a passenger aircraft takes off. You can feel that it's accelerating forward, but it's not huge. Okay, now if you're in a high-powered sports car with a crazy driver, okay, and they floor it at the stoplight, you're going to feel acceleration way greater than that. Okay, you're going to get thrown into the seat, and okay, you're going to feel like an acceleration that's probably closer to 1 G, at least in first gear. Okay, after that, that gets less and less. But okay, that sort of makes sense. Now, if you're in Top Gun, how many people have seen Top Gun Maverick? Okay, if you haven't seen Top Gun Maverick, see Top Gun Maverick. It made movies great again. Okay, it was just fun. Didn't have to think about anything. I just got to watch Tom Cruise, who I'm not really a huge fan of, just get to fly cool planes. It was just awesome. Yeah. Okay. It was just awesome. It was just like the first one, which was also awesome. Okay. Just kind of brings back the nostalgia. Okay. But in that movie, there are a couple of scenes where they are pulling high Gs. That means they're undergoing great acceleration. Okay. And in some cases, they were in excess of 9 Gs. Okay? That means that every part of their body weighed 9 times more than normal. What happens to those people?
Knocked out.
They get knocked out. They black out. Because their heart can't pump blood that weighs 9 times more than it's supposed to their brain. Okay? So the heart is like squeezing like crazy, but the blood just keeps coming back down because it's too heavy. Okay? Your heart was designed to pump blood at 1 G, not 9 Gs. Okay? It'll work for a little while, but after a sustained amount of time, probably more than about 30 seconds, okay, even a trained fighter pilot with the proper suit on is probably going to lose consciousness, which, spoiler alert, happens in one of the training scenes in that movie, okay, and they crash the plane. So, yeah, those accelerations are huge, okay? Those people would be accelerating at 89 meters per second squared to experience a force of 9 Gs. Okay, crazy. Okay. All right, so. We did that already. Okay, let's look at manipulating this formula. Rules of algebra. Okay, just a quick review of the rules of algebra. Let's say I want to solve for t. What should I do?
Multiply both sides by t.
Multiply both sides by t. Yep, absolutely. Okay, so I'm going to multiply both sides by t. T comes over here. What do I have to do with a?
Divide both sides by 8.
Divide both sides by a. All right, now I've manipulated that formula. I'm solving for t. Everybody okay with that? All right. What if I want to solve for VF? What should I move first? Alex?
I guess you add both sides by VI.
Okay, remember what our third rule of algebra is? Move what's not attached first. Are VF and VI attached?
Yep.
They are. Okay, there's an addition subtraction operation there. Okay, I am going to add VI eventually, okay, but it's not what I want to do first. What do I want to move first? T. Yeah. Okay, I want to get t back over here, multiply both sides by t. Okay, and now I want to add VI. All right, so I'm going to take VI over here. Okay. You thought that was just a mark on the page, didn't you? That's for my plus sign. Okay, now that's calculating VF. Okay, now I just want to take one step back here to this point. Is this the change in velocity on the right side? VF minus VI. Okay, so if I multiply time by acceleration, I get the change in velocity. When I want to calculate VF, I bring I bring VI over here. Okay, so mathematically, we can see what I did, but intuitively or logically, does this make sense? I take my initial velocity and I add it to the change in velocity. That gives me my final velocity. Does that make sense logically? Sure does. Okay, it's like going to work. Okay, I go to work with no money. I work for a little while. When I'm done work, I have a change in money. Now I have a new amount of money. Okay,
2 weeks.
right? What's that?
Every 2 weeks.
Every 2 weeks, or for me, every month.
Unless you
Okay.
get paid contractually.
Unless you pay contractually. Yeah, then it works differently. There's all kinds of different ways to get paid.
So do you add the VI after you've already multiplied, or do you add it to the T and then multiply?
No, order of operations. T times 8 plus VI. If you enter that into your calculator exactly that way, it'll do order of operations and give you the right answer. Yeah. Okay, good question. All right, let's say we want to calculate VI instead. What do I do different?
Subtract VF.
Okay, if I subtract VF, and it's a legitimate way to do it, it's not the way I do it, but it's a legitimate way to do it, okay? If I subtract VF, okay, over here, so I've subtracted VF from both sides, what am I solving for? Negative VI, which is okay as long as you remember the number you calculate is going to have the opposite sign of what it should have.
So you
Okay?
just multiply it by +1.
just
multiply by -1 or take the negative off. Okay, so I mean, that's only gonna matter, you know, for dealing with like north and south. Okay, so if you get negative, it's actually supposed to be north, which would be positive. Okay, so that you have to remember. I'm terrible at remembering that, so I never do it that way. Okay, what I do is just a little bit different. Okay, so right, what I do is I actually bring VI over to this side, just like I did when I was solving for VF. Come on. Okay,
Then you divide TA.
I don't divide TA,
Well,
I subtract it. Okay, remember, think order of operations. Would I multiply these two numbers together before I add it to that?
yeah.
So this is really not two numbers, it's one number. Okay, can I subtract that one number over to the other side? Absolutely. Okay, so what I do is if I want to find VF, I think about it more logically. Or sorry, if I want to find VI, I think about it more logically. And I say T times A calculates the change in velocity. So if I take my final velocity and subtract the change, I should get what I started with, VI. And it'll be positive, and I won't have to remember that when I calculated and came out south that it's really supposed to be north. Okay, because I mess that up all the time. Either way is completely fine. Okay, if you're really good at remembering that you calculated a negative number and you just switch the sign, go for it. Okay, I don't because I know I always mess it up. Okay, and then from a logical perspective, this makes sense to me. Okay, I go final velocity minus the change in velocity gives me what I started with. That makes sense to me logically. Okay, all right, questions on the manipulations? All right, here's what we're gonna do. Just like the mole equation, we're gonna do one type of question with each manipulation of the formula. Okay, so that we have one example in our notes of each kind. Okay, write this one down, give it a try. This one you can do, don't have to manipulate the formula, you're solving for acceleration here. So write your givens, show the formula, put in the numbers, calculate the answer. Okay, so a question like this would probably be worth 3 or 4 marks, okay, because you don't have to manipulate here. Right, so you get 1 mark for your givens. Okay, we know in this question the initial velocity is 0 meters per second. How do I know that? Starts from rest. Okay, reaches a velocity of positive 16 meters per second. What do they give me there? Final velocity. Okay, in 4.5 seconds, so that would be time. Okay, so knowing your units is going to become more and more important as we get into more and more formulas here. Okay, I need to know that meters per second is a way of measuring velocity. Seconds is time. Okay, meters is distance or displacement or position. Okay, all right, and they want me to calculate acceleration. All right, well, I've got a formula for that. Okay, A equals VF minus VI over T. Now, here's why we give you a mark for your givens. By the time we're done this unit, we're going to use every formula on that formula sheet. Okay, is that a lot of them? Does writing down your givens pretty much give you a way to figure out which one to use? All you have to do is match them, right? Okay, I have these things, that formula has these things, that's the formula I'm going to use. Okay, that's why you get a mark for those. And you generally get a mark for identifying the correct formula. Okay, I usually give a mark for plugging in the numbers correctly. Okay, so that would be positive 16 minus 0 divided by 4.5. Okay, so you probably get a mark for that. Okay, and then here's the thing we need to watch for. Okay, on this question it wouldn't make any difference, but on a question where that wasn't 0, it will make a difference. Actually, it would even make a difference here. The top needs to be in brackets. Okay, if you're going to enter this all in one step, you need to bracket the top. Okay, so you'd go 16 minus 0, okay, and hit enter or put it in brackets, okay, divided by 4.5, okay? Because if I go 16 minus 0 divided by 4.5, I don't get the same number.
Because 0 divided by 4.5
Is 0.
16 minus 0.
Right, so 16 minus 0 is 16. Do you follow the order of operations your calculator will do? Okay, so sometimes I'll put in brackets, like there's some physics 20 questions where we're entering like masses of stars and planets and all these other things in a big long line, and we'll just bracket everything. But oftentimes I'll just do one step at a time, okay, on the calculator. That way if I mess up, I can always go back up and grab the right number I had and start from there. Okay? So this should come up to 3.6 meters per second squared. Okay. Everybody all right with that? How did I know to stop at the first decimal?
Because there's a repeating decimal.
Okay, partly because it was a repeating decimal, but partly because of something I haven't taught you yet. Significant digits. Okay, we don't really go into a lot of significant digit stuff in Science 10, okay, but significant digits make sure that by doing math, we don't make our numbers more accurate. Okay, your accuracy is based on how you measure each number. If I divide two numbers that have no decimals, and then I get a number that has a whole bunch of decimals, I'm suddenly saying, hey, look at my number, it got more accurate. I suddenly measured it to like 10 decimal places when I didn't measure the two numbers I used to get it to that accuracy. Okay, you guys kind of follow there? So using significant digits makes sure I don't make my numbers more accurate by doing math. The only way to make your numbers more accurate is to measure them better. Okay, so on this one here, this number has 2 significant digits. This number has 2 significant digits. My answer can have 2 significant digits, 3.6. Even if it came out to 0.36, I would write 0.36, I would round it off, okay, at 2 numbers. Okay, it works a little bit different with adding, but adding and subtracting, it makes more sense. If I added these numbers here, 4.1 and 2.357, my answer can only have how many decimal places? What's my least accurate number? 4.1. Okay, because I only measured this number to this accuracy, my answer can only be accurate to that position. This number here is more accurate. It has more significant digits, but this number is being added to it. That creates uncertainty in the answer beyond that value. Does everyone follow me there? Okay, so my answer here would be 7, 5, 4, 6. Okay, and I would go, all right, I can only keep this number, so my answer is 6.5. Okay, I just have to reflect the accuracy of my measured values. I'm never going to test you on that, but know that when I do the questions, I'm always going to put them to the right number of significant digits. So if you're ever looking at your answer and going, why does my answer have 5 decimal places and CoderreScience only has 1? It's because I did significant digits. Okay?
For 3.6, since it was like 3.5 repeating,
Yeah.
did you just do 3.5 with like a little hat on top?
We don't generally show the repeating part if we're obeying the rules of significant digits. We say this is the last credible number. Round it off there. Okay. It also comes into play if you get a huge number after doing some operations, then you have to put it in scientific notation. Okay, how many people know how to do that? Okay, a little bit. All right, so scientific notation would mean if I got, let's say, this number, 405,327, okay, and I can only have 2 significant digits, okay, that means I have to stop my number there. I can't write those other numbers, okay? So what I would do is say, okay, my decimal is here. I'm going to move it 1, 2, 3, 4, 5 spots, and I'm going to say this number is 4.1 times 10 to the 5. Okay? Our numbering system is a base of 10, right? Every time you move over one spot, you're 10 times bigger or smaller. Okay? So that number is the same as that number. Okay? It's 4.1 times 10 to the power of 5, which would give you 5 extra spaces. Okay? All right. That's a little more than we need to worry about, but it came to my mind, so we talked about it. Okay, try this one. Okay, on this one, looking for how long. What are we looking for? Time. Okay. Give that one a try, and I'll do it in a few minutes. All right, so as with any physics problem, okay, we're gonna first write down our givens. How long will it take? Asking for time. Okay, a jet to accelerate from rest, okay, to positive 85 meters per second at a rate of positive 22 meters per second squared. Okay, how did I know that was acceleration?
Rate of.
Okay, it said it's changing its velocity at a rate of this, but what were the units for it?
Meters.
Meters per second squared. It's just a matter of I've got to know what the units for each of the variables I'm going to be solving for are. If I get something in joules, I've got to know that's energy. If I get something in newtons, I've got to know that that's force. Okay? If I get something in kilometers per hour, I got to know that that's speed or velocity. Okay? Everyone kind of follow me there? Okay. So these are the things I have. This formula has all of those things in it. Okay? And guys, I don't require that you put the arrows on top of it every single time. Okay? They're kind of a given, okay, in this case. I need to manipulate for time. So what do I have to do with t? Multiply both sides by it. Okay? And then do what with a? Divide both sides by it. All right. So I would have got a mark for the formula. I'd get a mark for the manipulation. Okay, and then probably get a mark for plugging in the numbers correctly. So that would be 85 minus 0 divided by 22. Whoop, missed the divide side. Okay, do I really have to put 85 minus 0? Did I just put 85? Yeah. Okay. All right, so I'm getting that this will take 3.9 seconds. Why am I not putting a vector on that?
Because we don't know the direction.
Well, it said the direction was positive. Time isn't vector, right? Time is scalar. Okay, making sense so far? All right. Solve for VF on this one. All right, so what will the final velocity of the race car be? So that tells us we're looking for VF. Okay, if it starts at positive 15 meters per second, what did they give me there? They gave me VI. This time it wasn't 0, right? Okay, and it accelerates at 7.2 meters per second squared. What did they give me? Acceleration. For 6.5 seconds, so that would be time. Okay, so we're back to this formula again. A equals VF minus VI over T, and I'm looking for VF. What should I move first?
T.
T, it's not attached. Okay, so I add T, or sorry, multiply T to both sides, and then do what with VI? Add it. Okay, so VI plus the change in velocity should equal the final velocity. All right, plug in my numbers. So positive 15 plus 6.5 times positive 7.2. You don't really have to put the positives in there, okay? Just the negatives if it applies. That'll give me VF. Okay, if I put that all in a line in my calculator, it'll work. Okay, plus 7.2 times 6.5. All right, so the final velocity of that race car will be 61.8. Actually, it'll only be 62 because I only have 2 significant digits. 62 meters per second, and it'll be positive. Okay.
61.8.
Yeah, I did significant digits, so I rounded to 62.
And then would you put it in 6.2 times 10 to the power of 2?
6.2 times 10 to the power 1.
Okay.
I would only move the decimal in one place, right? It would be here, and I would move it to here, so that would be one spot. Yeah. Right, because 6.2 times 10 is 62. Yeah, 10 to the 2 is 100, so that would be 620. Okay, everybody all right with that? I got to take that out of there, just take a decimal place. Okay, is direction important for acceleration? It is, because you're going to encounter some problems where something starts moving forward, but its acceleration is backwards. Okay, and so there's going to be a change in the direction between VI and VF. Okay, so acceleration's direction is going to be important. Okay, number 4, asking me to calculate VI. All right, so on this one here, how fast was a boat traveling initially? So we're solving for VI. Okay, if it accelerated to positive 30 meters per second, what did they give me there? That's VF. Okay, is reading comprehension a little bit important on these questions? Yeah, I have to get that kind of stuff, not just from the units, but also sometimes from the context or the wording of the question. Okay, at a rate of positive 2.6 meters per second squared, okay, for 8.9 seconds. Okay, so I'm looking for VI. This is my formula. What should I move first? T. It's not attached to VI. All right, so I multiply both sides by T. Now, here's where you have your choice. You can subtract VF, go T times A minus VF and get negative VI. Okay, that's not the way I do it. I add VI to both sides, and then I subtract T times A over there. So I'll have VI equals the final velocity minus the change in velocity, okay? And then I'll plug in my numbers. So 30 minus 2.6 times 8.9. Okay, so 30 minus 2.6 times 8.9. And this one I can enter all in a row. It'll do order of operations the way I want. All right, so its initial velocity was 6.9 meters per second, and that's a positive number.
What if you do it the other way and you have it as negative VI? How do you get it to a positive?
You just have to multiply by negative 1. Yeah. Okay, and again, that's why I don't do it that way, is because I always forget that. Okay, questions on that? Okay. Now, we already talked about that. Okay, this is one of the ones I was talking about where direction is important. Okay, I'm rolling a ball up a hill, but once it leaves my hand, which way is it accelerating? Backwards, down the hill. Okay, so direction is important here. Keep that in mind. Okay, you may have to, in this question, assign positive to one of the directions and negative to the other. All right, let's see how you do with this one, because up the hill and down the hill are opposite. We represent that mathematically with positive and negative. Okay, give you a few minutes to try it out. Okay, so this is a question that would be about as hard as they get, because it's got a manipulation, so you have to do some algebra, but there's also a contextual trick to the question. Okay, and that is something I have to get from reading it. It's kind of a reading comprehension thing. Okay, we start out, this is kind of like the lowest level of reading comprehension type of trick. Okay, by the time you get to grade 12, I think I told you this, you can sometimes get a diploma exam question where you read a whole page to answer like one multiple choice and one numerical response question. Okay, so being able to pick out the important information from the context of a story, okay, is going to be important. All right, so when you're in the English class and you're doing reading comp, don't think that that doesn't ever apply anywhere else. It totally does. Okay, it's just in science, it's more black and white. Okay, all right. So what I would do with this question says a ball is rolled up a hill at 4.5 meters per second, but it's accelerating down the hill at 2.1 meters per second squared. So what I do right away is I say, okay, vectors are involved in this question. I have opposite vectors, so I'm going to define up the hill as positive, and I'm going to define down the hill as negative. Okay? So when I write down my givens, I am going to say VI is positive 4.5 meters per second. Okay? Acceleration is negative 2.1 meters per second squared because it was down the hill. Okay, what is the velocity? So looking for VF after 3.5 seconds. Okay, everybody with me so far? So the only real trick here is this, assigning positive and negative to up and down. All right, now I go back to what we've done on the other questions. I write my formula, I do my manipulation, so A times T, okay, equals VF minus VI, then I add VI to both sides. Okay, then I plug in my numbers. 4.5 plus negative 2.1 times 3.5. If I forget to put that negative in there, it's going to say that when I rolled the ball up the hill, it accelerated up the hill. Okay? The only way that happens is if this is magnetic hill. Have you ever heard of that? Okay? It's in Ontario somewhere. Okay? But cars actually roll up the hill if they're not in like park. There's enough magnetism in the like nickel ore, whatever it is, or iron ore that's in the hill that cars can actually roll up the hill unpowered because they're magnetically attracted to something further up. It creates magnetic hill. You can check it out. Okay? So that's not happening here because this is a ball and it's a little hill. Okay? So I roll it, and once it's out of my hand, it's moving at 4.5 meters per second up, but naturally it's going to come back to me. Okay? It's going to accelerate back down the hill. So when I punch that into my calculator, I'll have 4.5 plus negative 2.1 times 3.5. Okay, and I get a reasonable answer. Okay, that it's going to be rolling backwards towards me at 2.85 meters per second. So here's the last trick. Actually, we only have two significant digits, so it'll be negative 2.9. This is not my final answer. I wasn't given positive and negative in the question. What was I given for vectors? Up the hill and down the hill. So my final answer needs to reflect the given vectors. My final answer is 2.9 meters per second downhill. Okay? If I write negative, it's wrong. I wasn't given negative. I assigned negative to that, okay? But my given directions were uphill and downhill. Okay? Everybody with me there? So you always have to convert back. We represent directions mathematically with positive and negative, but if we're given something else, compass directions, north and south, or whatever, we convert back to those at the end. Okay? And here's another thing that's going to seem really, really picky, and it is up and uphill are not the same thing.
Yeah, because one's on angle and the other's directly.
Exactly. One's up is directly up. Uphill is angled. Okay? Those are not the same thing. Okay? I know that seems really picky, and it is, but it's also true. Okay? Up is defined as vertically upward.
If you're doing both in a question, would you assign them both positive?
You couldn't be given one in a Science 10 question where you would have up the hill and up. In Physics 20, where we would deal with two-dimensional vectors, you could, but then your final answer would be at some other angle between up and uphill.
What happens if you named it up the hill is negative and down the hill is positive?
That's fine, you're going to convert back to up the hill, right? Your final answer isn't going to be positive or negative. So if you define up the hill as negative, okay, you'd have got positive 2.9, and then you'd have still written downhill, because you defined downhill as positive. So it doesn't matter what, that's why I defined it here, so that when I was done, I could go, I got negative, negatives down the hill, downhill.
Because I did it that way and I was kind of confused on how you did it.
Okay, does that make sense now, though?
Yeah, it does.
Okay. All right, guys, good job today. So tomorrow, no quiz, okay? But you'll have some time to work on your labs, probably only like 10 or 15 minutes, but it's something, okay? And then we'll continue on with acceleration on Friday.
Can we miss second period?
No, it'll be done, you'll be back here probably about 9:45, so right about when period 1 on the new schedule ends.